Good afternoon and welcome at this platform. My name is Muhammad Sabir, and in today's class, I will start a new topic. The name of the topic is integration. Okay, first, let's change the color of the pen. Uh, okay, okay, first, write the name of the topic, that is integration. Okay, that is the integration. Uh, when you heard a word, I think in earlier classes you have studied about the integration. Now the question is that what is the fundamental meaning of the integration? How we understand the integration? How we can relate the concept of integration to practical life? Can relate it or not? That type of question and these questions I will try to answer it in this session. Okay, and the first thing is that the concept of integration, where from it comes. Actually, you know about the summation concept. I think first write the concept of summation. The summation concept. Okay, the concept of summation. How we add the distinct number. Like this is also simple. Like when I will give a exercise to you. You have to add number series uh, 1 to 100 easily by using arithmetic progressions. You can add, and physically manually you also can add. Now the question is that when we come on the how to add the continuous function, how to add values we distribute in a continuous manner. Okay, how we add for that purpose, for to fulfill that purpose, the concept of integration comes into the picture. Okay, the concept of integration comes into the picture. Now the question is that how we can relate the concept of integration with a physical quantity. Okay, first I will give an example, and then I think you are able to understand uh, till now what I want to convey with you. Okay, and the first thing is that I think you have studied earlier what is the formula of a work done. What is the formula of a work done? I think the work done is simple, is the dot product of F dot S vector, dot product of force and displacement vector. First, I will tell you the validation of this formula. When we can apply this formula. Okay. Now the question is, let's is the ground, and a block is at a ground, and a force is applied. The force is applied on a block, and due to this force, actually the block moves, and it travels a distance s. It travels a distance s. Okay. Now the question is that during which journey the force will be constant. It does not vary with uh, time and displacement. In that time, we can use this formula. Okay. Now we change the scenario. We change the scenario. The scenario is so simple. Now our interest to find out the work done or a path. Like we have a block of mass m, and a force F is applied on a block, and due to this force action, the body travels, it change a position x1 to x2. Okay, now the question is that now the problem is that here the force varies with displacement. Okay, the force is not a constant. It a varying quantity. Okay, and now the question is that its varying quantity is a f is a variable, is a variable. Okay, it's a function of x, whatever it has. Now, how to deal this scenario, how to handle this scenario. First, we compare, we always try to make this case, like first we try to find out a displacement where we can say the force becomes constant for that instantaneous displacement. Okay, let's take a dx element. Like we assume that uh, the body is the body is at a x is at a x position, and now the force is at this position on a block is f at a particular instant. And when we apply the force on a block uh, at a particular instant is f and position is x, and let's assume that the body travels a displacement dx at a smaller in a small displacement. We can say that the force is to be a constant. Okay, and we can uh, write the small work done due to the small displacement is dw, and this f dot dx. Okay, and now we add the all smallest work done. We have to add all the smallest work done over the path start from x1 to x2. And now the concept of integration comes into the picture. This is a x1 to x2. By using integration we can get, okay, it becomes a whole work done from over a path from x1 to x2. And it simple integration by using integration law you can solve. Okay, but in today's class our purpose is to how to apply the concept of integration rather than uh, mug up or mug up mugging up of formula that we don't focus. Okay, and let's move to the mathematical modeling of integration, how we can solve the integration problem, and what is the mathematical meaning of integration, and how to handle the problem of integrations. Okay, okay. First, I have to add a slide. I have to add a slide, and let's change the. Okay, and now the question. Now the time to understand what is the mathematical meaning of integration. Okay, mathematical meaning of integration. Mathematical meaning of integration. Simply, you know that uh, it's a simple formula. X is to power n into dx. What will be the integration of this function? Or simply n plus 1 plus c. Okay, this is the simplest formula. You can remember it easily. And first thing is that now the question, uh, I will write a line. Uh, the integration and a differentiation is uh, like reverse. a reverse process. Integration and differentiation is a reverse process. You, uh, I, I will explain. I like uh, output of any integral. Like this is the output of this integral. Okay, when we differentiate this integral, we have to get original integral function, and then we can say or a function the function which I'm integrating is like is a it also can output of integral also when we differentiate the same function we will get. Okay, in that time can say ki in a both side uh, the integration and differentiation follows reversibility process. Okay, that's a simple discussion. I think you are able to understand what I want to say. And now the another thing is that the area under the curve concept. Area under the curve. Area under the curve. This is so fundamental concept. I think you have to understand. Like we have a we have a Cartesian coordinate system here, y-x plot. Okay. Now our interest to find out area which is covered by this curve from x-axis. Okay, now our interest to find out what will be the area of this saddle region. I think you know we always know the area of a simple shape. Okay, like we know what is the area of the rectangle, what is the area of the triangle, what is the area of the square. Okay, it's a random shape, or you can say it's a random shape which is mm, subtended by a curve, and over a x-axis we have to find out what will be the area of a certain region. Now we divide into a rectangle of a certain area. First we divide into uh, first we divide into a small rectangle cube area. Okay, let's take a this rectangle is at a position x. Okay, the length is px. You also know at a x position the value of the function is y, and you know what is the area of the rectangle. It's a simple dx into y, and when we add the area of the rectangle for the rectangle, then we can get the area of the shaded region, the area of the shaded region. Okay, shaded region. Okay, this is the so fundamental concept. Okay, I think you are able to understand what I want to say, and keep learning, and thank you, all the best. And you have any doubt, you can ask me. Thank you.